So how do we use the factor theorem in order to find the zeros of this polynomial function? Well, first thing is we have to look at this factor. And we're going to use this factor in conjunction with this thing called the factor theorem in order to then determine the zeros of this function. Remember, the zeros is just a complicated way of saying the locations of x where this function crosses the x-axis. So first, what is the factor theorem? Well, here it is. It says that the polynomial x minus k, which is basically what we're considering the factor over here, okay? It will be a factor of a function f of x, this is f of x, if and only if the function's value evaluated at k is equal to 0. Basically what this is saying in English is that if the remainder, if you divide this factor into this polynomial function and the remainder is equal to 0, well then you know that this is indeed a factor, okay? This is what is called the remainder theorem I'm using here. So the factor theorem is related to the remainder theorem. If you need help with the remainder theorem, just take a look at some of the videos of this playlist on our channel. So basically what we can do, and we can do this now a whole bunch of ways. I think what I'm going to do is I'm actually just going to start this bad boy off with synthetic division. And when I do that, I'm going to divide this polynomial into that polynomial, and I'm going to be looking for the fact to see if the remainder is indeed equal to 0. Okay? Let's take a look. Okay, so now since this is basically what we're looking to do, we're looking to take this polynomial and divide it by this polynomial, we know that we can use the process of synthetic division in order to do this because the divisor is a linear function. In other words, it has a coefficient here and that's a 1, so that's fine. Even if it were a 2, you could still do this. But you have basically a linear function being divided into some type of polynomial function. It doesn't matter if it's cubed or squared or whatever the case is. All right? So how we go about this now is the number of columns of your synthetic division table must equal the highest power of your function plus 1. So that's why I have 4 columns. So basically inside of the first one goes your x cubed term, next is x squared, next is just x to the first, right, or just x, and then your constant. So the coefficient of the x cubed term is a 2, so you plug it in. The x squared is a 3, so you plug it in. That looked like a weird 3. This one is a 1, and then your constant is a positive 6. All right, so they're all positive, so I'm just going to leave the sign out, and it's assumed to be then positive. Then what you have to do is you have to figure out what number goes here. In order to do that, basically just take your divisor now, set that bad boy equal to 0, so do x plus 2 equal to 0, solve it for x, right? You would subtract 2 on both sides, and this turns out to be now the value you're going to plug into here, okay? So -2. Now you're going to follow the following series of steps. You're going to drop this first number straight on down all the way to the bottom. That's supposed to be an arrow. There you go. Then what you're going to do is you're going to take the bottom number, multiply it by the outside number, and you're going to put the result in the next adjacent cell, so -4. Then you add this column on up, so that's a -1. Then you repeat the process. Bottom number, multiply by the outside number, so that's a +2. Add that column on up, so you get a 3. That number multiplied by that number, which is a -6. Add that on up, and look, 0. This column now at the bottom represents the remainder. And if I tested now this factor out, and when I divided this factor into this polynomial, if I get a remainder of 0, then I know, this is the factor theorem, that this is a factor. Okay? So, what are these values now at the bottom representing your synthetic division? Well, this represents the remainder. This is the constant term. This is the coefficient of your x term, and this is the coefficient of your x squared term, ... You probably detect the pattern. It's not going to match what we did at the top, so that's not a mistake. It just doesn't match. So we can now write our answer. So in other words, when you do this division, okay, it's going to equal 2x squared minus 1x, or just minus x, plus 3. And that's it. All right? Now, what I can do is I can do a little bit of algebraic manipulation now, right? Since this is in the denominator on the left, I can multiply both sides of this equation by this value. And that has the same effect of just kind of, you know, if you think about like a cross multiplication or something like that, it has the effect of just bringing that on across. So let's bring it on across. So just you cross multiply it basically. All right, and now you have a polynomial function. Let's erase this line. Okay, so this is still the same equation. You have this, well, it's a polynomial, but it's quadratic, right? You have this quadratic equation now multiplied by this factor. Okay, so you know one of the factors. And whenever you know a factor, okay, that's what we proved before by using the factor theorem. Whenever you know a factor, you can always find the zero by setting that factor equal to 0, right? Because you're finding what you're doing is you're saying, okay, what value of x makes this thing go to 0, all right? So I kind of already did that. So basically what I did in doing this is I found the zero already. I didn't know it was a 0, right? Because just because you can set this thing equal to 0 and then solve, it doesn't mean that this is a 0. This is only a 0 if your remainder, when you do the division, is a 0. So one of the zeros of the function is going to be -2. All right. Now what we need to do is we need to find the other zeros. So this is pretty actually straightforward at this point. In other words, what I need to do is I want to find the zeros now of this function. And this is a quadratic function, right? This is a quadratic. I already found the 0 for this factor. Now I want to find the zeros for that. Now we can do this in a bunch of ways. The most surefire method, if you're not allowed to use your calculator and stuff, is going to be to use the quadratic equation on that, right? So that's basically going to be x, I'll write it out, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So it's like, well, how do you know to use, how do you know to use that, right? Well, it's all about pattern recognition. That's the benefit of doing a lot of practice, right? I see this and alarm bells just go off in my brain. I have an x squared term, I have an x term, and a constant, right? I have the following form, ax squared plus bx plus c. It's all about pattern recognition. So once I recognize that, I'm like, oh, it's a quadratic. How do I solve for the zeros? Oh, right. Okay, quadratic formula, right? Or equation, whatever the heck the name is. So your a value is going to be 2. Your b value is going to be a -1. You have to incorporate that, right? Because there's really a 1 in front, so -1. And your c value is going to be a 3. So you can go ahead and plug this on into here, do your algebra, and then you'll get your values. Or if you're allowed to use your calculator, you can use this program. And if you want a link to the program, check out the description. It's like a 3 or 4 minute video. I walk you through how to program your calculator, and you're going to love it because watch how nice and simple this is. So what's your a value? 2. What's your b value? -1. What's your c value? 3. And there are the zeros. Now it turns out that they are imaginary. Okay, they are imaginary, but those are indeed the zeros. So the x value here, now if they wanted only the real roots, right, or the real zeros, well, you would have had one answer, all right? But it doesn't, okay? Now this also, the calculator gives you it in decimal form, not necessarily radical form. So it depends. You might need to convert that into a radical, in which case then you would probably want to do the math on out here. But all you would do is just don't simplify. Well, you'd simplify the radical, but don't get rid of it. Don't actually take the radical. So this is basically going to be x is equal to 1/4, right, 0.25, plus then, I'm just going to round heavily, 1.2i, and x is also equal to then 0.25 minus 1.2i. So you do have 3 roots, or zeros, because it's a cubic. Now, you can also graph this thing if you want to gain a little intuition, all right? So the only problem, though, with graphing this is that you're only going to see across the x-axis one time. You're not going to see it on a real coordinate system. You're not going to see these because they're imaginary. So if I were to graph this, 2x cubed, so just plug it in, 2x raised to the third, all right, then do plus 3x squared, plus x, and then you're going to do a plus 6, right, plus then 6, and graph it. Notice how it only crosses, so it comes up, comes down a little bit, and then whoop, goes on up forever. So notice how it only crosses that x-axis one spot at -1, -2. -2. All right. That's how you do it. Hopefully that helps, ladies and gentlemen. I really appreciate it. If you loved this video, like, subscribe, maybe even tell some of your classmates. That's really the best. Help us spread the word. We really want to help more people. And basically our future is in your hands. So no pressure. No pressure at all. Thank you again. By the way, check out our channel because we have thousands of videos, not only in math, but physics and chemistry as well. We solve specific problems, as you can see, because guess what you're going to see on your tests and your exams? That's right, specific problems. So we teach you how to problem solve. Take care.